Alright folks, so what I wanted to do is a quick video on the Ailunce HD1 by Retevis. It's a DMR and analog handheld ham radio. The point of this video is to do some testing around the power output and the antenna impedance, as there are some rumors around the internet around an antenna impedance mismatch or some kind of problem with the radio that would prohibit users from using a aftermarket antenna and only using matched antennas supplied by Retevis. Before we get started, I did want to say that I was sent this radio by Retevis for testing and evaluation purposes, and that means I did not pay for this radio. Folks are saying that there is a design flaw with the radio causing it to expect an impedance from an antenna different than 50 ohms, which is the standard for handheld ham radios, and actually all ham radios. Personally, I really don't care if there's an antenna impedance mismatch or not. I just need to know if I can use aftermarket antennas. For example, I may want to use a roll-up J-pole if I'm out in the field so I can get higher elevation and perhaps more gain than the stock antenna. Retevis does sell an aftermarket antenna that's bigger than the one that comes with the radio and has better gain. For the testing, we're going to use some sophisticated equipment, like the Nisei RS40 SWR and power meter, along with an MFJ dummy load. The MFJ 261 is rated for 15 watts continuous or 100 watt peak. It's a dry dummy load, and I have no idea what that means, but anyhow, it kind of looks cool. First, we're going to test the SWR, the stock antenna, on low, medium, and high, and we get 1.2, 1.3, and 1.5. Don't worry, we'll go over these results later in the video. We're doing these tests on the 2 meter calling frequency, so these are 2 meter band tests. And for power, what we saw across low, medium, and high was 1 watt, 2.25 watts, and 7 watts. I kind of estimated. The analog meter is not entirely exact, so you kind of got to guess where the needle lies. Running through the test on a known 50 ohm dummy load, low, medium, and high, we see 1-to-1 SWR. Because I know everyone will doubt the accuracy of the dummy load, I used a separate radio to go ahead and perform the same tests, and I was able to replicate the 1-to-1 SWR using the BTEC 6X2. Now we're going to run through the power tests again, low, medium, and high, using the MFJ dummy load. And what we get are 2 watts, 4 watts, and 8 to 9 watts. Now we're going to run through the same tests using the signal stick antenna. I'll include a link below. It's a very popular antenna, highly recommended by everybody who buys it. As we run through the same tests with the signal stick antenna, there's a couple of things that we notice. Low, medium, and high SWR ratings are 1-to-1, 1.2-to-1, and 1.3-to-1. And the power output ends up being 2 watts, 5 watts, and a little bit over 10 watts. So what we're seeing from this antenna is better output and better SWR than the stock antenna. The better results of the signal stick antenna don't indicate an impedance mismatch with the radio. We didn't see that either with the dummy load. What it does indicate is that the antenna supplied with the radio, much like every radio on the market, isn't the best antenna, and that you're better off using an aftermarket antenna than using the factory antenna. Because all of our results are showing normal operation, we're not really seeing anything that would be unexpected. What I wanted to do now is just run through the same tests back with the dummy load on the 70 centimeter band, or 440 frequency. And what's interesting is that we see that the SWR for low, medium, and high ends up being 1, then a little bit higher than 1, so I'll call that a 1+, and then a 1.2. So I think that that would be within range. As we go through the power settings, we see 1.2, 3 plus, so a little bit over 3, and then we see a very surprising 15 watts on high setting. Now for me, this indicates that there's something wrong. What I did off camera is I ran the same test with the stock antenna, and I adjusted the power output on the meter to go up higher than 15 watts. And we ended up getting about an 18 watt output. And I think that that's probably what caused some of the confusion or concern around this radio and the antenna. The radio definitely shouldn't be putting out that much wattage. Now if you're using an aftermarket antenna that's not rated at 18 watts, it might get hot. And we did see some examples of people posting on the internet where their antennas melted. So my recommendation would be not to use aftermarket antennas on this radio at high settings on the 70 centimeter band. I wouldn't even use the factory antenna at that point. So here you can see the test results. On the row labeled stock antenna, I have low, medium, and high, and then the power output ratings is advertised for the 2 meter and then 70 centimeter bands. And so what you can see as you go through using a stock antenna, the dummy load, and the signal stick are the power outputs aren't exactly as advertised. I don't think the power output or the SWR ratings are anything to be concerned about, except for on the 70 centimeter band on high power. It really shouldn't be rated that high at 15 to 18 watts of output. And to me that's a little bit concerning. So I just wouldn't use that power setting, which is a little bit of a bummer, but if you're using the medium setting with a high gain antenna, you should be able to make the contacts that you're looking for. For me, these results wouldn't prohibit me from buying or recommending this radio, and it wouldn't prohibit me from recommending using an aftermarket antenna. What it would do is prohibit me from recommending use on the 70 centimeter band on the high setting. Anyhow, if you have any ideas or would like to see it tested differently, go ahead and comment below. If you have any questions, you can post them as well, and I'll do my best to answer them. I want to thank Retevis for sending me this radio, and I want to thank everybody for watching the video so far. I really appreciate it. Thanks.